Alrighty, if we want to convert this radian to degrees, well, what we have to do is we have to take 8 pi over 5 and we need to multiply it by a fraction of 1, which is pi over 180. That is 1 with different units, basically. And the reason I chose 180 over pi is I wanted the pi's to disappear. And when I do that, if I multiply now 8 times 180 divided by 5, you will get 288 degrees. So that is a quick way to convert. Now for this problem, we're going to take a 140 degrees and multiply it by a fraction, but this time we're going to put pi over 180 because I want the pi on top. I want to make a radian. And when you reduce this one, the zeros kind of cross out, and you reduce 14 over 18, you get 7 pi over 9. So there would be a radian conversion. So you're basically just going to multiply by 180 over pi or pi over 180 so that you either put a pi on or take a pi off, basically. All right, next problem. If we want to do this right here, find the sine of 120, that means we want the y value at 120. So I draw that little unit circle there to help me. 120 is right about there. So if I look at that, if I want the y value at that point, it would be the square root of 3 over 2. Next, if I want 5 pi over 4, that would be right here, down here, right about there. Okay, for 5 pi over 4, I want the x value, this is cosine. Actually, the x and y are both the same at this spot, so you can get lucky. But the x value would be square root 2 over 2, but it'd be negative, because it's in the negative quadrant over there, where both x and y are both negative. And again, cosine one's x, sine one's y. Now this next one, 5 pi over 3, 5 pi over 3 would be down here. Okay, now for tangent, you want y over x. The y value here is negative square root 3 over 2. And the x value, when you divide, you flip and multiply. So the x value is 1/2. So when you flip and flip 1/2, you get 2. And when you reduce that, you will get the square root of 3. Just don't forget it's negative. Those are a little bit more complicated. Tangents make it trickier, or a little bit trickier. All right, 3 pi over 2 would be right down here. So if we're thinking about that coordinate, if we put rise over run, or y over x, because tangent again is y over x, this one's going to be, well, your y is 1, or negative 1, and your x is 0, so anything divided by 0 is undefined. So we are undefined there. All right, last little bit. We're going to sketch these graphs. All right, so the first thing I want to do maybe is look right here and put the asymptote marks. So I'm going to make this a 1 right here. I'm going to put my asymptote. Sorry, what did I say? Not my asymptote, my midline. I said it wrong. So I'm going to put our midline on there. Sorry. Asymptotes come with tangents. I'm going to put a line out here. That'll be my period. And I'm going to break it up into quarters. What would be this period out here at the edge? Well, it would be 2 pi divided by, which means multiply by the reciprocal of this. So you divide by pi over 4. So when you do that, you get the pi's cancel, so you get 8. So I know that this value out here is going to be 8. The period is 8. That's p equals, period equals. Again, you take 2 pi divided by the b value, which is right there. All right, so next, it's a cosine graph and has a negative a value. So it has this negative 3a value there. So what that means is we're going to go down 3. So this is here at negative 2, and we start there, because cosine starts either the high or low from the midline. So it's also going to end right there. Halfway through, it's going to hit the midline. And then in the middle here, it's going to be up 3. So we need to now go 1, 2, 3. So it'd be here at 4. So in the middle, you would be right there. So that would be our graph. So then we sketch our cosine graph here. And we are done. If this was a sine right there, you'd be starting right here, going down, back here, up, and back to there. But it's a cosine. If that was a positive 3 there, we'd be starting here, ending there, and this dot would be flipped. All right, last one, tangent. If we're going to do this tangent graph, first of all, again, we need to get our midline. All right, so that's -1, so I'm going to draw that midline in. I'm going to mark off my period here, which is right here, and mark the quarters. You should know that for a tangent, you have an asymptote right down the middle of that. The period comes from here, so instead of 2 pi divided by that, you're going to go pi divided by 3 pi. Hopefully you understand there's a 1 hiding right there. That leaves you with 1/3. So the end of this period is 1/3. So now, to graph tangent, you basically graph a sine graph. So a sine graph starts at the midline, ends at the midline. You kind of have a dot here, but it's kind of pointless. You don't need the dot here in the middle because it's an asymptote. But we need a sine graph. So it's a +2, so it's going to go up like this. That would be sine. So let's find our sine dots, but we don't graph a sine graph. Okay, so +2 means we go up 2. So we're going to have a dot right there. And then -2, and then down 2 right here, we're going to go down 2. So those are my dots. But those dots, again, here is the sine graph, but we really want to graph a tangent through it. So what a tangent would look like is something like this. Go up and up against that asymptote. And then it would go through here and down against that asymptote. Something like that. Not the best drawing, but tangents, use the sine dots, have an asymptote down the middle, and have this breaking at asymptotes.